Lesson 3.3. Instead of kind of giving you a little explanation, I'm actually going to jump right into the exploration down here. Now, you may not have a protractor at home. I actually had to run to the dollar store and pick this up because I didn't have one at home either. They're all at school. But that's okay. So if you don't have a protractor at home, you can kind of just watch mine. So it says draw a line. Now, it doesn't really matter what angle I put this at, so I'm just going to draw a line here. And it says label a point on that line. Now it says make a 65-degree angle from that point. So I'm going to 65 degrees. I don't love how this one does it. That's okay. I guess I don't have a choice. It'll be okay here. It's just the way this is kind of thick. I don't know where it's going to actually fall. You know what? I'm just going to kind of... Again, I'm not used to this protractor as much. This in-between area here is kind of big for my pencil. Okay, so now I'm just going to connect this. Okay, so I just made a 65-degree angle right there. Okay? Now it says the line that you just drew to form that angle, let's call this the transversal. So I'm just going to shorten this just a tiny bit here. And we'll call this the transversal. All right. Now it says place another point on the transversal line. Okay, I'm just going to put it down here. I could put it above or I could put it below, but it's kind of thick up there, so I just put it down below. Now it says at that point and the transversal line, make another 65-degree angle. So I'm going to basically have to go like this way, 65 degrees, because I can't really, I don't know, I have to come from the transversal. So let me just turn my paper a little bit here. And so 65 degrees, I'm going to have to go this way. Again, this may not be as accurate as I would like because this protractor, kind of goofy the way it is down the middle here because my pencil lead is thinner than this area. Okay, but we're going to make it work. Yeah, I'm going to go like that, potentially. Again, no, that doesn't even look very good either. I don't love this protractor, but it's what I could find. So 65 degrees. All right, let me erase this. Let me see if I can get a little bit better of a 65-degree angle. Okay, I guess we'll have to just make it work. So 65 degrees right there. Okay. They have to be good enough. Okay. So this is 65. All right. Get so used to the protractors I have in class. I'm not used to any other protractor. Now, that doesn't look the greatest, but it says, what conclusion can you make from your drawing? What you're supposed to notice is if you look at these two angles, those are corresponding angles. And what you've done is you've started, so you started with corresponding angles. And then you're concluding something about the lines. And so what you're supposed to be noticing is that these lines are parallel. But again, based on my protractor here, I'm not sure that this is really a good 65 degrees here. But that's the equipment I had, so that's what we're going to be working with. And so if you notice the title, it says more with parallel lines. So in today's lesson, if you notice in the theorems down below here, you'll see the word converse, okay? If we go back to yesterday's lesson, do you notice that they all started with if the lines were parallel? You have to remember that the converse is going to reverse your statement. It's going to bring the Q part first. So if we look at our statement, the Q part is the angles are congruent. So if the angles are congruent, then the lines are parallel. So they're just reversing it. So if corresponding angles are congruent, then the lines are parallel. That's what today's lesson is all about. And we also talked about abbreviations. See how we use CAT for corresponding angle theorem? Well, today's lesson is about the converse. So they're going to call this CAC for corresponding angle converse. They just dropped the theorem part. So all of these, all three of these, except for the last one, because you probably don't know the last one yet, but the next three are going to be the reverse of what we did yesterday. So again, if you look at yesterday's lesson, every single one of them started with if parallel, then angles. So we've got to reverse that. So we're going to say if alternate interior angles are congruent, then the lines are parallel. And so we're going to call that AIAC for converse. Do the same thing for alternate exterior. So if alternate exterior angles are congruent, then the lines are parallel. Now we got to be careful on this next one. Okay, we've talked about this before. Do you want to use the word consecutive or do you want to use same side? I really like same side, but you could do either one, okay? So if I'm going to do same side interior angles, but if you want to do consecutive interior angles, you could do that too. But be careful. These ones were not equal. They were supplements. Okay, so we got to be careful on that one. So say if same sides are supplements, then the lines are parallel. Okay, so we're going to either use corresponding angle, consecutive interior angles converse, or we're going to use same side interior angles converse. Okay, now we could do the same thing with exterior. So I'm just going to kind of put it off to the side here. If you want to do same side exterior angles converse, we can use that too. But if we're going to do exterior, we can't use consecutive. We have to use same side because otherwise the word consecutive doesn't work. So these are all the same from yesterday, okay? This last one is just a new theorem from the lesson. So this is what you're used to. Transitive property, I don't use a ton. I don't use a lot of transitive because, remember, transitive only works in certain situations, but substitution works in all of them. But the title of the name is transitive, but if you want to think of this as substitution, it works as well. Let me just show you what it looks like. Basically, what it tells you is if you have two lines parallel, and your book uses P and Q. So let's say you have line P, which is parallel to line Q, okay? So these are parallel. And Q is parallel to R. So now we've got a third one in here. So Q is parallel to R. Notice how the Q's are side by side. That's the only way transitive works. If this would have been reversed, you can't use transitive. But because the Q's are side by side, we can say, well, then P must be parallel to R, which does make sense. And so for me, I would almost think of this as a postulate, but it is listed as a theorem because you can prove it using their slopes. So that's why they list it under the theorem category. Now, this is not something we use a ton, but it does come up from time to time. So I definitely would, work on, I don't want to say memorizing it, but it's kind of one of those things that you just have to have like as in your back pocket as a bag of tricks that you can pull out and use. Okay. All right. So now let's go to some problems. So if you look at page 7, on page 7, the first 4 questions are asking you if there's enough information in the diagram to conclude that the lines are parallel, and it doesn't necessarily have to be, oh no, it is all M and N. Okay, I saw S and R there. So if to conclude that the lines are parallel, and then give a list of your reasons. Now, it says list, so sometimes there might be more than one, sometimes there's only one. So we look at number 7, and we say, okay, these angles are same side exterior. And if we add those together, so if we take 75 plus 105, we get 180. So because these are supplementary, I would say yes, there's enough information to conclude the lines are parallel by, now I'm going to use same side exterior angles converse. The angles are supplements, therefore the lines are parallel. Do you notice none of these pictures have parallel lines, marks? So this lesson, we're trying to conclude the lines are parallel. Now, the book doesn't use this justification. So what the book is going to probably do is the book is probably going to use something like maybe a linear pair. So they're going to calculate this angle to be 105, and then they're going to use these as corresponding. So do you see how it says give a list of reasons? So your book is going to say yes by linear pair postulate and corresponding angles converse. Now, again, if you want to use same side, I'm fine with that. I just want you to know, if you reference the textbook, what they're going to use, okay? So we can try one more together, and then why don't you try one on your own, or two on your own. So if we look at number 8, we're looking at M and N. So if we look at M and N, if we look at the marks on M and N, they're telling us they're congruent. Now, we don't necessarily know what they are, but we do know they're congruent. So as long as they're congruent, we can say, okay, yes, the lines are going to be parallel because these are corresponding. So we'd say corresponding angle converse. Now, I sometimes get asked, what if you leave off this C? Will you get marked down? And the answer is yes. You'll get a half a point marked down. Because if you just tell me they're corresponding, that doesn't necessarily mean the lines are parallel. It's the converse that tells me they're parallel, okay? So why don't you pause the video here and try 9 and 10. Okay, hopefully you tried 9 and 10. If you look at 9, these angles, those are vertical. Verticals do not tell you the lines are parallel. So I would just say no, because we have vertical angles. That doesn't tell us anything about the lines being parallel. If we look at number 10, we have to kind of ignore this line down the middle because we don't really need it. So if we look at these two angles, you kind of almost have to give the reason first. So when I look at those are alternate exterior. So that's enough. So I would say yes, because we have alternate exterior angles converse. And again, you got to put that C in the back. So those are just, again, using those converse theorems. Now, number 11 is, again, kind of the one that the last theorem that we added on here, because the easy way to pick it out is you have 3 different lines. And so if we look at number 11, they're asking us, is there enough to say that Q is parallel to R? Because if you look at the marks don't match. But the answer is yes, there's enough information. And really what it boils down to is what we have here is we have P is parallel to R. And then we have P is parallel to Q. Now the way this is written, you actually can't use transitive. So what I would need to do is I would need to flip this around. So I would need to say R is parallel to P, and then I would still keep the P is parallel to Q. Because now, if you notice, these two match up. So we could get rid of these. And then we have R to, whoops, I wrote this wrong. This should be Q. I shouldn't have switched that. That's Q. So then we would have R to Q. And then again, do you need to switch it again? Because notice how it says Q to R. So it's a lot of flipping letters around, but what it boils down to is yes, the transitive or the transverse property of parallel lines. I want to call it transitive, but it's transitive. Transitive. Sorry, for some reason I was thinking transverse because it's a transversal line. So transitive. Good thing I wrote in pencil. Too many words that start with the letter T. So it's the transitive property of parallel lines. Again, I was thinking transversal here. Okay, last couple problems. We got 2 algebra ones, and then we got your favorite thing on the very back, okay? All right, let's get through this. So we look at this, and now it's saying find the value of x that makes the line parallel. Again, do you notice there's no parallel lines marked, okay? So we don't know the lines are parallel. We're trying to basically prove it. And notice it says give a reason. So we're doing really the same thing that we did above. It's just now we have numbers. So when I look at number 12, I'm looking at this saying, well, these are corresponding. And if I can get these to be congruent, then I can use the converse. So right now I'm just kind of saying corresponding. So corresponding or equal. So I'm going to make my equation. And I'm going to go ahead and solve this. Okay, so I get x to be 5. So if I plug that back in, notice I got 95, which means my corresponding angles would be congruent. So my answer is x is 5 and corresponding angles converse. Those are my 2 answers because using this number, it makes the converse statement true. So again, in a way, you're kind of giving the justification, the reason before the solution, but you just want to double check and make sure your answers work out. So why don't you pause it here and try number 13? It might be a little hard to see on my projection, so if you want to look at your hard copy, that would be better. Okay, so in this particular one, these are going to be same side interior, so same side interior angles. Now again, if this works, it's going to be the converse, because if you just say same side, it doesn't tell you the lines are parallel. So let's work this out. Now remember, same side are supplements. So I'm going to add these together. Now I'm going to go ahead and distribute this out. So this will be 2x plus 30 plus 3x plus 20. So I added those together and I'm going to set it equal to 180. Okay, that would be 5x plus 50. I'm going to subtract the 50. I'm just kind of solving this. 130. And now I've got to divide by 5. And I get 26. I just divided by 5. So I get 26. Now, I'm hoping that my algebra is right, but let's plug it back in, okay? So I'm going to plug it back into both angles. I'm going to go 2 times 26 plus 15, and that makes this angle up here 82. 3 times 26 plus 20, that makes this angle 98. And if I add those together, notice they are supplementary. So I know I've done this right, so I'm going to add the converse on, and there's my answer. So these would be worth probably more than 1 point because, again, not only do they want the value of x, but they want you to give a reason. And so this would be your reasoning, okay? So again, you could really envision that they could ask you any of these. So it could be corresponding, it could be alternate, same side. I was just trying to kind of pick a variety of questions, and so that this doesn't take too long. If we look at the back, we've got kind of a bigger challenge question here for number 14, and then we have everybody's favorite, the proofs, okay? So let's do number 14. So in number 14, they're asking us for the values of x, y, and z that make the lines parallel, okay? And if we notice the lines right here, do you see how those match up? We can almost answer this question first, but we still need to know the values just to make sure it works. Otherwise, we would say no down here. But if the values all work out, then we know what property this is going to be. Okay, so let's just start with x because I don't know, it comes first in the alphabet. So I'm looking at x, and it's a little bit hard to see which one x goes to, but I'm assuming it's probably this one because the way it's written, where that starts, so it makes more sense that it would go here than over here. So we're going to use it as this one. So if we look at those two angles are alternate exterior. Okay, so I'm just going to kind of keep a note to myself. So x is alternate exterior angles. Well, alternate exterior are equal. So I'm going to set them equal. So I'm going to multiply this out. So that would be 3x minus 3. And then that's going to be equal to 4x minus 30. So if I move my x's to the left, I get x. And if I move my numbers to, my variables to the right and my numbers to the left, this would be 27. Okay, so I'm going to get x to be 27. So let me just plug that back in and make sure here. So 3 times 27 minus 1, this would be 78. Do the same thing here. 4 times 27 minus 30. All right, we know we've done that one right, so we're good. All right, now if we look at y, because that would come next in the alphabet, notice there's no other y to pair it with. So what I'm noticing is that these are a linear pair, which is great, but the problem is I would have two different variables. These are vertical, but there's nothing here. So 78. These are corresponding. So for the y value, I'm actually going to use corresponding. Now again, it's not really asking me for a justification, but it's good to kind of continue to use those properties and think about always why you're doing what you're doing. So for y, I'm going to use corresponding. So that 78 is equal to 6y. And basically, I'm just going to go 78 divided by 6, and I get y to be 13. And it should work out because the only thing I did was divide off the 6. I really didn't do much other algebra, but if we just kind of plug it back in, yep, notice this was 78. So we know we've done it right. Okay, now we only have one left, and that's z. Now again, z is vertical to the one right here, so if we know this angle, we could use that. Or these are a linear pair. So you really have either option. I kind of like vertical because it wouldn't be that difficult to find this angle. So if we just take 180 minus 78, we get this angle to be 102. So if this angle is 102, we could just set those equal. So we could do 102 is equal to 6 times this. And again, yes, I'm going to multiply those out. I was just kind of showing you you're setting those equal. So let's go ahead and just distribute. Actually, so for z, I kind of used linear pair and verticals. I kind of used two of our old properties. Okay, so now I'm just going to subtract off the 48, and I'm going to use my calculator here. So nothing fancy, just subtracting off the 48. And then I'm going to divide off the 6, and I get z to be 9. And if we just quick plug that back in, notice we get 102. So we know we've done that correctly. So based on all of our calculations here, we've got all the right numbers to make the converse. So we're making the converse work, okay? So based on all of our numbers here, is P parallel to R? And I would say yes. Now, if you want to know your explanation, honestly, there's lots of answers to use because if we know all of these lines are parallel, we could use the transitive property. Now, you should say of parallel lines, but if you just said transitive, I'd give it to you. But you could also notice if you use 78 and 78, you could also use alternate exterior angles converse because you've just shown that the alternate angles are congruent. You could also use same side exterior angles converse because you've just shown that those are supplements. So there's actually quite a few different answers that you could give under the explain heading. All right, last problem here is a proof. Now you're going to notice every now and then you see these goofy little boxes. That's because this is a Google Doc. And Google Doc, for some reason, does not like our symbols. I don't know why, but every now and then it messes up our symbols. So those are supposed to be congruent symbols, okay? So we've done proofs before, and you know that the first box is always just recopying the given. So we're just going to do that. Now you know the last line, but I'm not going to fill that in right now because we'll have a tendency to want to like maybe use it. So we know that 1 is congruent to 2, and we know 3 is congruent to 4. Okay? Well, think about, if you look at this picture, 2 and 3 are vertical. Now, I don't know if that's going to help me, but let's go ahead and write that down. So 2 is congruent to 3 because they're vertical angles. Okay? So let me just mark this. I've got 1 congruent to 2, and I've got 3 congruent to 4, and now I've said 2 is congruent to 3. Well, doesn't that make them all congruent? So all 4 of these angles are congruent, okay, which is really nice. However, I'm trying to get to the fact that AB is parallel to CD. So that's what I want. So if that's the goal, if the goal is to get these parallel, don't I need to prove angles are either congruent or supplement? That's the whole idea behind the converse at the top here. You need to show a certain type of angle. Well, I don't have same side because these two right here don't touch the parallel lines. So I don't have same side, but I do have alternates. So if you look at angles 1 and 4, so if we get rid of everything else, 1 and 4, if I extend these lines, aren't 1 and 4 alternate interior? And if we can show that these are equal, so if we can say that 1 is equal to 4, then can't we say the lines are parallel because of the converse? So that's what we're trying to get to. We're trying to say that these lines are parallel, and we're going to try to use the alternate interior angles by the converse. So notice I've already kind of done my last line. I just need to say that 1 is congruent to 4. So I need 1 congruent to 4. But what am I going to put as my justification? So you're going to want to use the 2 lines above. You're going to want to use these together. And if I could give you a small hint, we haven't used the most commonly used property. So if you look at this, 2 and 3 are the same. So what you're doing is you're really getting rid of these 2 and you're putting this one in its place. Or you can do 1 in its place over here. It doesn't matter which way you go. But this is substitution. Substitution, again, is one of the most commonly used properties. So in this lesson, all you're doing now is you're trying to get to the lines are parallel. But remember, the only way to get lines parallel is either to calculate slope, which would be extremely difficult since we don't have any ordered pairs, or you have to use your converse. But that concludes the lesson.